Hello everyone, I welcome you to this video that would give you a brief introduction to the events of Robotix 2008. To know more about the events, you can have a look at our site www.robotix.in and www.ktg.in. I would like to bring this to your notice that last year our website was www.robotixIITKGP.org, and this year we have shifted our domain to robotix.in, and mind it is robotix.in. So the following presentation would provide you with the basic idea of all the problem statements of Robotix 2008. So in case of any query, you can mail us at contact@robotix.in. Robotix is an annual robotics competition organized by the students of IIT Kharagpur during their Techno Management Fest called Kshitij. Being a competition of international level, it provides a platform to robotics nerds all over the world to showcase their talent by competing against their allies from faraway places. Now, coming to robotics in IIT Kharagpur. It started with a mere intra-institute competition in the year 2001, and today it stands as the country's largest robotics event, with Robotix 2007 witnessing more than 1500 students from across the nation. If we have a look at the statistics, Robotix 2005 saw 220 teams from 45 colleges across the nation, amounting to a total of 550 participants. Coming to Robotix 2006, the number of participants rose to 750, which made Robotix the largest robotics competition of India. But as if that was not enough, Robotix 2007 was yet to come. Over 1500 participants, 546 teams, international participation. What more can you ask for? And how big a leap can you ask for in just 1 year? We got online submissions from universities like Princeton and Stanford in our programming event called Mission Mars. Finally, Robotix goes international. Now, apart from organizing the robotics competitions, the robotics team of IIT Kharagpur also organizes workshops inside IIT Kharagpur and throughout the nation in the major cities to spread the spirit of robotics. In these workshops, we teach the fundamentals of robot making that would enable even an amateur to make her or his first robot. We teach about structural design, mechatronics, embedded systems, computer vision, and image processing. In the last 3 years, we have conducted such workshops in Bhubaneswar, Hyderabad, Ranchi, Jamshedpur, Jaipur, and many other major cities of India. So if you are interested in any such kind of workshops in your college or in your city, you can contact us at contact@robotix.in. Now, coming to the events of Robotix 2008. We would be having 2 mechanical events called Terra Ranger and Statistics, 2 autonomous events called Robo Relay and Image, and 1 programming event, Mission Mars, a legend in itself into its 4th year now. Now coming to the first mechanical event, that is called Terra Ranger. In this event, the task is to make a mechanically controlled robot which is capable of traversing on various surfaces like undulating surfaces, sand, water, etc. In this event, the bot will also have to cross a pit by placing a bridge over it. So the robot should have a mechanism that should pick up a bridge, carry it and place it over the pit to cross it. Now if we come to robot specifications, the robot should be a manually controlled car with the required mechanical setup. No Lego kits or complete car bases are allowed, and the dimensions of the robot should not exceed 25 x 25 x 25 centimeter cube. Now coming to the arena, as you can see here, the arena is a wide closed track with different regions as marked. You can see here sand, undulating surface, pebbles, obstacles, water. Then a bridge is placed over here, and here is the pit. Here is the start finish line. The inside of the track will not be having any boundary walls. Here the bridge will be having hooks attached to it so that the robot can pick it and drag it. The hooks and the weight details of the bridge will be notified very soon on our website. The maximum depth of water would be 20 centimeters. Now coming to the obstacles, the positions of the obstacles would be released just before the event, and the obstacles would be wooden blocks. The pit over here would be of depth 15 centimeters. Now coming to the rules of the event, the robot has to start from this start line and it has to traverse in the counterclockwise direction. So it has to come to the sand, then undulating surface, pebbles, going through the obstacles in water. It has to come to the bridge, pick the bridge up, place it over the pit, cross it and reach the finish line. If the robot misses out any of these zones or is unable to complete any of these zones, it will stand disqualified. There would be certain checkpoints at various places on the track. Now in case you want to restart with your race, you can take a restart, but that would cause you a penalty of 40 seconds. Also, if the bot leaves the confines of the track, a penalty of 40 seconds would be imposed. A maximum of 2 restarts are allowed, and each time you take a restart, there would be a penalty of 40 seconds added to your time. If the bot is not able to place the bridge on the pit, it will be disqualified. Coming to the next rule, only one robot per team will be allowed on the arena at any given instant of time. The maximum voltage that can be used for powering the bot is 20 volts DC. Arena specifications will remain the same for all the rounds, but in the higher rounds, the rules of traversing the arena may change. For example, you may have to go clockwise. Now let us come to some basic issues that you will encounter while making a bot for this event Terra Ranger. Firstly, you have to make a drive that will enable your robot to traverse over such terrains like undulating surfaces, sand, pebbles, water. So the drive that you make should be strong and efficient. And a very simple drive that would give you these qualities is a differential drive. So you can go for a differential drive. Now if you don't want to use any of these drives, we would really appreciate if you come up with some innovative ideas like a hovercraft or any such new mechanism. Again, special attention must be paid to the type of wheels that you use and the height of these wheels. So this is an event, this is a mechanical event of whose difficulty level has been kept very low, so that even first year students can participate in it. So we wish you a very best of luck and hope to see you in the Terra Ranger event. Now we move on to the next mechanical event, that is called statistics. Here, the task of the bot would be to assemble blocks of various pre-specified shapes and dimensions and to arrange them to form a given spatial structure. Now, what makes this event different from other mechanical events? It is that you can use more than one robots in this event. Each robot should be a manually controlled vehicle and the overall dimension should not exceed 35 cross 35 cross 50 centimeters. Now what do we mean by that? By that we mean that initially when you start up with the event, the initial orientation in which your robots will be kept should not exceed this given dimension. And once your robots have been placed in that initial orientation, you cannot touch any of your robots. Now coming to the arena, as you can see here, the arena is a 5 meter by 2 meter polished plywood base and it would be enclosed by a boundary wall of height 10 centimeters. It would be divided into 2 equal parts. Now each part would have 3 zones, zone A, zone B and zone C. Coming to the rules now, zone A is the place where your bots will start from. So you have to place your bots in that initial orientation here in zone A. Zone B is the area where the blocks would be placed and the position of these blocks will be specified just before the commencement of the event. So you have to come from zone A to zone B, pick up those blocks and move to zone C. Now zone C is the area where you have to place these blocks in the given structure. The structure would be specified. The structures for the first 3 rounds would be specified on our sites very soon. But just to give you an idea that what kind of buildings you have to make, say you have a cuboid. This is the top view. So you have to place 2 cuboids like this, and you can place a cylinder here. This might be one of the structures that you have to make, or this might be a sphere too. Say there can be another cuboid here. So you have to place 3 cuboids and a sphere between them, or a cylinder between them. Now you can also encounter discs in this event. But how will you pick up discs? Well, the discs will be of this kind. This is the side view. At the center of the disc there would be another block attached to it, so that you can lift it from here. This is the top view, this is the disc, and here is that cylindrical block. This is the cylindrical block and this is the disc. So maybe we can ask you to lift this disc up and place this disc on the cuboids. So you can be asked to make any such kind of structure. Now coming back to rules, all the blocks would be numbered and each block would be associated with certain number of points, and the points would be proportional to the difficulty that you would encounter that to pick up that block. For example, picking up a cone would fetch you more points than picking up a cuboid. Touching a block would disqualify the team immediately. So touching any block at any instant of time is not allowed. The maximum amount of time for the first, second and the third rounds is 4 minutes, 5 minutes and 10 minutes respectively. Now here we have something for you. You can take timeouts if you want. Now when can you want to take timeouts? Maybe if you are going from zone B to zone C and you have the robot is holding a block and it drops that block and the robot is not able to pick that block again. So you can go for a timeout. Or maybe in zone C, suppose you have already placed block 1 and while placing block 2, block 1 falls and now you are not able to place block 1 again in that orientation. So you can go for a timeout. Here in this event, a timeout would not mean restarting the whole race again. You can take timeouts corresponding to certain blocks. For example, if block 1 falls, you can say block number 1 timeout. The time would be paused. Block number 1 would be placed in block B in its initial position. The robot would start from where it stopped and the time would be started again. So you can take timeouts for one block, maybe more than one block. If you take timeout for more than one block, it would be counted as a single timeout. Number of timeouts in round 1, round 2 and round 3 are 1, 2 and 3 respectively. The rules for the next rounds would be disclosed at the time of the event. Now coming to the block specifications, the dimensions and the shapes of the blocks to be used in the first 3 rounds would be very soon updated on the website, but the probable shapes may be cuboids, cubes, cylinders, spheres, cones, etc. Now how do you have to place these blocks on the arena in zone C? Let us have a look at that. Suppose this is zone C and say you have to place just 2 cuboids here. So on the ground, on the surface, there would be marks made like this. And you have to place your cube, you have to place the block inside these marks. There would be some margin given. So your block should come inside these marks. If the block goes outside these marks, it will not be counted as placed properly and you will not get marks corresponding to such placed blocks. Now we come to the scoring rules. To move from first round to the second round would be completely time dependent. You do it the fastest, you come to the next round. For the second round onwards, the score will depend on the sum of points corresponding to the individual blocks that you place correctly in zone C. Also, that score would depend on the time. If there is a tie in the scores of two teams, then the team doing it in lesser amount of time would be given preference over the other team. Now let us talk about some points, some basic issues that you would encounter while making a robot for this event statistics. To start with, you will be making a base for the robot. Here you need a very precise control over the movements of your bot. So again, to make it to just keep it simple, we would prefer a differential drive because it can be very easily controlled and it can be precisely controlled. Now comes the crunch, that is the arm. You have to hold the blocks very efficiently, and the problem is that the blocks range from a cube to a cone. So the fingers of the arm should be flexible. Now maybe you can use multiple links in your fingers. Okay, we are not talking about how are you going to make the arm, because that is where you have to think. So think about it. The robot that has got the best arm, the robot that can hold the blocks the most effectively wins here. So think about it. Also, you have to provide a degree of freedom to the arm of the bot so that it can move upwards and downwards, and that can be achieved very easily by using a thread and pulley mechanism or a rack and pinion or a nut and bolt. But we would prefer a rack and pinion mechanism because that is very efficient and that is very fast. Thus the basic requirement in this event is that you have to pick up the blocks and place them with accuracy. So pay attention to the arm that you are making. Now again, I would like to notify that you can have a look at the rules on our website www.robotix.in, or you can mail us your queries at contact@robotix.in. And now we move on to the autonomous events.